Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem having been chosen from the same book, Paul A. Tipler. Okay. As usual, we first come to its statement. Okay. Calculate the distance or not between the K positive and Cl negative ions in KCl. I think potassium and chlorine and then potassium chloride. Okay. Calculate the distance or not between the potassium and chlorine ions in KCl. Assuming that each ion occupies a cubic volume of side or not. The molar mass of potassium chloride is 74.55 gram per mole and its density is 1.984 gram per cubic centimeter or centimeter cube. Okay. Yes, students, quite simple. We have to just use a formula and our problem will be solved. We see how many snapshots we have chosen. We have chosen only one snapshot for this problem. Okay. Only one snapshot has been chosen for this problem, and that is Avogadro's number. Okay, so first we come towards Avogadro's number. Actually, dear students, we are dealing with this term from our middle school level, but nevertheless, because this concept, this term is involved in this problem, so it is quite appropriate to revisit, recapitulate, revise that concept or term. Okay, so Avogadro's number. One mole of a substance contains Na, where capital A is written as a subscript of capital N. Okay, Avogadro's number. Avogadro's number is denoted by capital N, capital A, where capital A is written as a subscript of capital N. One mole of a substance contains Na elementary units, usually atoms or molecules, where capital N, capital A, where capital A is written as a subscript of capital N, is found experimentally to be Na equal to 6.02 to 6.02 into 10 to power 23 per mole, within bracket Avogadro's number. Okay, meaning this is the definition of Avogadro's number. This is the concept of Avogadro's number. Okay, now dear students, we are going to develop a foundation regarding use of the formula in this problem. Okay, dear students, it becomes quite clear whenever we use some formula or expression to derive some required value, we must know all parameters which are involved in that formula or expression. Okay, so in other words, we need to develop a foundation of the expression in which everything is explained clearly, that what is what stands for what. Okay. We consider each ion to occupy a cubic volume of side R naught. Okay, we have made a supposition assumption that we consider each ion to occupy a cubic volume of side R naught. The ions occupy a volume of 2 Avogadro number into R naught cube. Okay. The ions occupy a volume of 2 NaR naught cube, where capital A is written as a subscript of capital N, is equal to 6.022 into 10 to, dear students, here 6.02 is only written, but it is 6.022. Okay, anyhow, even if we do not write 2 or write 2, it does not make very much difference. Okay. Where Na is equal to 6.02 into 10 to power 23 is Avogadro's number. The density rho, okay, this symbol is called rho. The density rho is thus related to equilibrium separation R naught by rho equal to m over capital V equal to 2m over 2 NaR naught cube. Okay, dear students, density is denoted by Greek alphabet rho. Okay, so above we have said R naught as a cube volume of side R naught, and here to the same R naught we are saying that it is equilibrium separation. Okay, both are equivalent terms. Okay, the density rho is thus related to equilibrium spacing R naught by rho equal to capital M over capital V, becoming equal to capital M over 2 NaR naught cube. This implies that if we rearrange this expression and shift R naught cube on other side of equality, then rho will become in the denominator in place of R naught cube. Okay, in other words, we have shifted both these factors. Okay, in place of rho, R naught cube has been shifted, and in place of R naught cube, rho has been shifted, while the intermediate portion is just as an equivalent expression, so we do not take that as a central factor. Okay, so this implies that R naught cube will be equal to capital M over 2 Na rho. We have given equation number 1 to this expression, and this expression is the only tool which will solve our problem absolutely. Now in this expression we will use these values. Okay, using rho equal to 1.984 gram per centimeter cube or cubic centimeter. What is this? This density is not only given in the statement, but also there are a lot of tables in the books of solid state physics in which this value is given. Okay, so dear students, even if this value is not provided in the statement, we can find such values from their relevant tables. Okay, moreover, capital M is given in the statement as 74.55 gram per mole. Okay, similarly this value can also be found from relevant tables, but fortunately here both these values are given in the statement. However, the value of Avogadro's number Na is a very famous and very basic value. Avogadro's number This is, I think, never provided in the statement. We have to take it from tables, or we have to remember it. Okay. So dear students, in this expression, that is equation number 1, we will put these three values. Out of these three values, two values are provided in the statement, while third value has been taken from snapshot, which is about Avogadro's number. Okay, so when we will put these three values in equation number 1, we will get R naught cube equal to capital M over 2 NA rho. Okay, in place of capital M, we have used its alternate values, that is 74.55 gram per mole. However, 2 is as it is, and in place of Avogadro's number Na, we have used its alternate value 6.022 into 10 to power 23 per mole. And in place of rho, we have used its alternate value 1.984 gram per centimeter cube. Next, dear students, just simplification, nothing else. Just simplification. Just simplification. Dear students, here we see from where this factor, that is 3.12, has come. Okay. Dear students, when we will multiply 2 with 6.022, and the result of this, which will be about 12, when we divide 74 by this value, okay, we will multiply 2 with 6.02, and then we will multiply it with 1.984. This is roughly equal to 2. This is equal to 6. Okay, 2 into 6, 12, and 12 into 2, 24. Okay, so when we will divide 74 by 24, then definitely answer is nearly 3. So this 3.12 is due to this, while 10 raised to the power 23, which is in the denominator, when shifted to a numerator, will become as minus 23. Okay, into centimeter cube. Dear students, we are seeing here that centimeter is in cube, while we are not concerned with centimeter, we are concerned with meter. Okay, because we follow MKS system. Okay, so dear students, we know that centi means 1/100th part. Okay, so when we convert centimeter into meter, we have to multiply with 1/100, or in other words, we have to divide it by 100. But here centimeter is in cube, so 100 will also be multiplied 3 times. Okay, so it will become 1/1000 into 1000. Okay, in other words, 10 raised to the power 6 will be in the denominator, and when shifted to a numerator, it will become 10 raised to the power minus 6, and hence 10 raised to the power minus 6 and 10 raised to the power minus 23 will become 10 raised to the power minus 29. Dear students, this is the value of R naught cube, while we have to find out the value of simply R naught. For this purpose, we will have to take cube root of both sides. Okay, that is R naught cube power 1/3, and this factor will also be taken 1/3 power. Okay. So dear students, when we have to take 1/3 power of right hand side, then it is desirable that this 10, this meter is already in cube, but this 10 raised to the power minus 29 is not seeming appropriate. It should be either 30 or 40 or 50 or 10. That is to say, it should be divisible by 3. Okay, so in order to convert it in minus 30, we reshape this number as 31.2 into 10 to power minus 30 meter cube. This implies that R naught becomes equal to 1/3, that is cube root of this, that is power 1/3. So this 3 will be cancelled with 3, 1/3, and this will become minus 10. Okay, R naught will become 31.2 into 10 raised to the power minus 10 meter. Now we know that 10 raised to the power minus 10 is not very much important for us. For us, what is important is 10 raised to the power minus 3 or 10 raised to the power minus 6 or 10 raised to the power minus 9 or 10 raised to the power minus 12 or 10 raised to the power minus 15. So we will convert this 10 raised to the power minus 10 into 10 raised to the power minus 9, so that it may be written read as nano. For this purpose, here we will have to shift decimal one stage backward. So it will become 3.12 into 10 raised to the power minus 9 meter, and minus 9 is equal to nano, and hence our R naught has finally become equal to 3.12 nanometer. And this is the end of our problem. This is the end of our solution. This is the end of our video. Till next video, Allah Hafiz.